All right, so we are back again, and can you guys guess what we are going to be doing today? So we are going to be doing coordinate geometry. Coordinate geometry. So this is what we are doing today. So normally, people call it y equals to mx plus c straight line. So this is mainly everything that has to do with straight lines. The first video. So this is part one, and this equation and this, they are the same thing. So people are used to the first one, and this is the same thing as, uh, so they are the same thing. Okay, so it doesn't, anyone you know is fine. You don't need to know both, but if you know both, it's still fine. Okay, so I'm just, like I always do, this is like a summary. I don't want to bother yourself, okay? I don't want you to bother yourself learning, uh, okay, studying. Make sure you always practice. So the first thing you should know is this. So this is gradient. So this is gradient. So this is m, and it's equals to y2 minus y1, x2 minus x1. And this is a y-intercept. Intercept. Okay. So that is what we've seen now. So this is the first and second thing you should know about equation of a line. So just put that. It doesn't matter. Any other you just need to know. Now let's say, uh, now remember it's a straight line. So if I have a line like this, so this is my y, this is my x. If I have a line like this, so this is my c. So I can find a gradient using rise over run. So here can be your x1, x2, x1, y1, x1, y1. Then the other point can be your x2 or x2, y2. So this is, then you can use the formula for gradient. So this is the first thing to know. Then the other thing to have in mind is, now similarly we can also have a line like this. So for this, m will be positive, and for this, m will be negative. So take note. So this is an increasing, this is increasing, this is increasing, this is decreasing. So keep that at the back of your mind. So sometime when you calculate, always check. Then we're moving on. So similarly, we can have two types of gradient. Okay. Uh, if I have a line like this, these are parallel lines. For parallel lines, so this is M1, M2. So M1 is equals to M2. So for parallel lines, the gradients are same. Take note. Then for perpendicular lines or orthogonal lines, so this is M1, M2. So M1, M2 is equals to minus 1. Again, you are not here to prove. When you get to a higher institution, you can prove that. Okay, but if you want to know the proof, just write in the comment section, then we'll see. Or people say, and the second gradient is negative reciprocal of the other one. So this, so whenever they say perpendicular or they are at right angles to each other, or you see 90 degrees, then this is always true. Okay. All right. So we can also have a distance formula. So distance, okay. Before I move to distance formula, there's one very important thing you should know. So imagine I have something like this. Let me make it, let's say I have something like this. Something like this. I said, remember, you can take this gradient and this gradient, this point to find the gradient. Let me say I'm taking this. Taking this to find my gradient. So like I said, this is my rise, the distance between them. This is my, or the, you can say distance. This is my run. So x2 minus x1, x2 minus x1, y2 minus y1. Do you know that? So like I said, gradient is rise over run, or y2 minus y1. You can, if you know your trigonometry, this is also tan theta is y over x. This is also true. So if here, so to find the angle, so the gradient is related to tan theta. So you can get the angle when you know the gradient. So theta is tan inverse of m. So when you know the gradient, you can find the angle. When you know the angle, you can find the gradient. So take note. So this is another thing you have to keep in mind. All right, like again, if these are very important points. Once you understand these things, trust me, this topic will be piece of cake. Trust me when I say piece of cake. Okay, moving on. Moving on. Distance formula is x2 minus x1 squared plus y2 minus y1 squared. That's the distance formula. Okay, so we're going to see how we can apply these to solve the midpoint formula is x1 plus x2 over 2, y1 plus y2 over 2. I think I will give one example, then I will use it to explain most of these formula. Okay, so that's the midpoint formula. So this is just a rundown. Like I said, I'm giving some hot tips on solving questions and what you need to know in each topic. So if you need detailed explanation, or you have a question, or you have an examination question for us to solve, bring it to our attention. All right, choose.